Let me start with the SABIC headquarters. By the way, SABIC is one of the richest oil company in the Middle East. This project particularly, you can see there are fins all made of steel mainframes. Why? Because it is a bomb blast. The parts of the steel structures that I've done, for all the buildings that you've seen there in the elevation, I've put in all of these points. This points is where I am hanging those colored. I'm hanging all my frames and facade on those points. Before we started this project, we have asked the EOR and the consultant to give the loads that we are putting in this building, like live loads, facade loads, the steel frame loads. All of those things we have to calculate with a factor of, let's say, 0.75, because not all the time there will be full people inside the building. So we have to agree in a room on which values, like factor load, that we have to put in for the pre-cumbering. In this project, we have to pre-cumber on site because we are taking in the steel at 20 feet long, each up to 36 feet long trailer, which is bringing on site, and this 36 feet, they're putting it like a splice connection in between to put in together. So this steel, each individual steel, if you see that machine there, the green ones, okay, each part of the member we are pre-cumbering according to the calculated values on the yellow column. I don't know if you can read that. It's 50 millimeter, 100 millimeter, even at the HVAC or the machine rooms, really is going down. And we cannot hang our facade because our facade is, as you can see, a unitized curtain wall system. So a unitized curtain wall system, we have a 33 millimeter. This 33 millimeter, and we are putting it, bracket is on top of this. There's a line there. It says facade up. So this 33 millimeter, we cannot go down or up. It's like a 1 millimeter and down for 1 millimeter. It should be straight, or else you will have a problem with the facade all throughout the building. So this is like you have to follow this strictly. And on times, we have to pre-cumber on site. We're already installed, and we have to push it further up. As you can see, there are two types of unitized curtain wall system. You already know unitized. This part is like a male-female, wherein the male and female are continuously connected from top to bottom. So I'm going to discuss in the following projects another type unitized curtain wall system, wherein the male and female are the same. And why are we doing this type of structure? Just try to see the loads that we are putting in the building. Okay. This is a 57 PSF wind load. This is the address residences in Dubai Opera. So what happened here is that there is a big facade contractor that has like delays on their projects and had problems dealing with the consultant, the steel contractor and the consultant. Actually, the facade consultant already approved the steel frame. I was hired by that company and 4 of my teams, like designers, to go on board and fix their delay, help them with the submittals, and help them with this particular problem.
Hey, Ivy, are the loads that you're talking about for the wind factored or service loads?
Service loads.
Service loads.
Yes.
Okay.
These are all service loads.
That does seem,
There's a
Wind. Yes.
It does seem.
wind load study, like a wind tunnel study.
Yes, everything. Actually, all of my projects are like coming from wind tunnel tests because these are tall buildings.
Okay. So is that at like a corner of the building that's just like in the regular wall zone that?
Yes,
okay.
The corners will go up to like 70, 80, and helipads will go further up.
Wow. Is that because they have a lot of the wind storms there that, bring in, like
it's
dust and the
there are a lot
sand?
of tall buildings
Uh-huh.
beside.
Yeah.
So now the winds are passing through the corners.
Yeah, it gets compressed and yeah.
Because of so many tall buildings now there.
Yeah.
The problem here is, if you can see on the right side, that is the top view of the steel frame there's a problem. Okay. Now, because of this deflection, if you can see on the left side, the rectangular ones are the ACP panels. On the right side, I have like 100 millimeter deflection down. On the left side, I'm having like 30, 40 millimeter. ACP cannot go down, cannot twist like that in that manner because you have a sealant. You have the screw, which will tear down as you twist the ACP panels. The steel frames are all going down because there are no stiffeners. There are no tension rods provided. So what happened is that when we align, aside from the ACP problems, when we align the curtain wall on this area beside on the green part, that steel area on the top part, there is a clashing and an opening of the curtain wall because the steel went down. So we were unable to install the facade. So I went through a series of meetings actually with WSP and the steel contractor. And since this is a big cost, there's a big cost involved in adding up those steel frames that we are requiring. I have to do the entire modeling and show them that this is the problem. And as we go along, as we have the whole day meeting, and because these are consultants, they do not want to admit that they had made the mistake and they will cost money to the contractor. So they're asking for like war break and they're bringing in their structural engineers because we're putting pressures on them. So eventually they gave in and they put in this tension rods and all of these stiffeners. This is actually the last project, Al Wasal Tower in Dubai. If you can see on the background as Ben, this is the tallest building in the world. Yeah, so it's just a few steps away from my project. This is the Burj Al Arab.
Oh, the one with the pointy is the tallest
Yes.
building in the world?
Tallest
How
building.
tall is it?
It's 1,000, more than 1,000 feet. And my project also is 1,000. This is a 302-meter facade. So you see the wind load. This is 87 PSF. Wind load plus internal wind load of 9 PSF. Plus these panels that you can see, the fins. This is a ceramic facade. So it's like 115 PSF. So if you add this up, I'm going about 200 PSF loadings on this building. With a moment, the facade is like this. I'm hanging it in this direction, and it's twisting all over, okay? So now I'm gonna show you the system. This is actually the last project I did from 2021 up to May 2023 before I left for US. Okay, now you see this on the right side. This is like a new type of unitized curtain wall system wherein the male and the female are the same. And there is a big gap in between. So why are we doing this? It's because when we do the opening, like twisting of the building, we are only changing the bottom part of it and putting on extra, like, so you can, as the building is turning, your opening down is also turning. And we are not going to change much of the profiles on top. And how we connect these two together is that we have this on top. There are two bottom brackets at the bottom, and all throughout its length, we have 6 like a lateral torsional buckling clip, but bigger. So we have this buckling clips on top. So what you do is that you put in the curtain wall down. No matter what the angle is, you can put it down. And then it's already locked in the wind load. Then at the bottom, the left side is a lateral, free at the sideways, and the right side is locked. So once it's locked like this, you cannot move it anymore. So this is like more, we can adjust it more than the typical male and female. So if you can see how we are analyzing this one, for how I am analyzing, by the way, for this entire building, like the SABIC, it's one-on-one. Means one engineer for one project. This project from 10th floor up to the helipad is also mine. So I have one engineer in the office, is also senior engineer, taking care of the ground to 10th floor, which is unitized panels. So all of the, stick curtain wall. All the unitized panels are in my scope. It is high wind loads and live loads and moments. We have to do this. And the brackets are like not in this direction, but it's hanged in this direction. You hang it like this because the building is twisting like that. You have to model it all in finite element analysis so that you can have the stress analysis. Plus, after all of this analysis, we have to go to the testing on site, like a prototype, visual and actual. Yeah.
So what software are you using?
This is that. By the way, if you can see this, the one below, this is the tallest ceramic facade in the world right now. So the height of this facade is 6.61 meters, which is around 20 feet, that we are hanging on the curtain wall itself. And this one is going out, as I've said, going out, bottom, going out on the top. So it's everywhere. You cannot have like one calculation for this one. And the extension of the bracket is tabulated below, which is around 204 here, 294, which is around 12 inches. So the extension from the bracket, extending from here up to the outer part, is around 12 inches. Now, how we do the bracket is also through finite element analysis, because as you can see here, we are hanging left and right, and these brackets are like modeled in, putting a stiffener, and then trying to see where the stress is. But at times we have a small fin. So what we do is that we cannot have two brackets like hanging. So we are hanging it like using one bracket, fabricated, all fabricate. As you can imagine, it's not like a typical one panel and you can do all together. Any question on that? I'll go on the second part. This is the bridge actually from the tent. There's a and then there's a bridge connecting these two buildings. Now, I have the steel frame. So you have the steel.
Are these Revit views? Do you know? Are those Revit
Yes,
views? Okay.
there are B modelers also doing this and Revit
Okay.
designers. So this steel frame has like a 350 plus minus moving in the lateral direction. And there is a diaphragm for the building diaphragm that is put in the left side, and it's like opening up like an accordion type. And we have to close this thing up so that, water and everything, moisture will not come in. It should be like there's a damage, can easily put it out, and you have to install a new one. Up and down, I also have like a 12 millimeter up and down. Here on the steel frame, an FT10, which is a cladding panel on top of and bottom, is attached on steel frame. And also there is a louvers in between and the curtain wall on the top and bottom. I'm hanging the FT10 on the stick curtain wall panel. And then these panels are installed on the steel frame. I'm gonna show you, this is the top section of the steel frame. I don't know if you can read, this is in this particular area alone, I have put up around 30 or 40 or even 50 types of brackets, customized brackets for each.
Wow.
Why? Because on this area, on the typical area, we have this bracket type. It's easy, it's flat. As you go along and turning on this part, we have steel clashing with our bracket. So now I have to customize everything and fit in all these things as we turn around on dead load and wind load bracket. And at the end, we have the curtain wall. By the way, this is the curtain wall, where the curtain wall is. That section on the right part and on the left part are curtain walls already. So we don't have anything to attach it on, since at the bottom of the curtain wall, we already have another curtain wall. So how I put up the bracket is that there's a steel stiffener inside. I have put up all this fabricated steel and put the bracket on the concrete. So in this particular project, we have like thousands and thousands of brackets. And these are just like a few areas that I'm showing from the building. So this is the stone cladding now. I have modeled the stone cladding actually in 3D as well, finite element analysis, to get on with the stress of the stone panels and how I am fixing it on the frame at the back. So the topmost part is the dead load, bottom is a wind load bracket. Let's go on to the Dubai International Hotel. It's a point fixed glazing. It's located in the Terminal 3 of the Dubai International Airport. So this is pretty much a straightforward design wherein you have you have a point fixed glazing and spliced at each how many floors? On each of the green items. You can see the green. This splice are put in there. This is like it's quite tall. If you can see the airport, it's quite tall. So I'm putting it all of this point fixed glazing at the 950 bracket on each. And on the top floor and the bottom, it looks like this. So using Hilti sometimes, and all are customized as well.
Can you back up one slide?
Okay.
So is it what is the back member? Is that a glass?
It's a glass with a glass fin.
Yeah. So it's glass fin.
Yes.
So it's laminated. And you did that as well.
Yes.
What are the dimensions on it? I can't read that dimension up there. What's the thickness and the?
No. Here. I can show you a little, but it's a double glazed. It's a double glazed glass.
72.5 millimeters by 670.
Yeah.
So two pieces glass laminated together with
No, four.
four pieces glass laminated together.
This is 4 pieces glass laminated together.
Oh.
PVB or SGP? What's the laminate?
It's SGP because you cannot use a PVB.
Yeah.
It's not possible to use a PVB on this.
Yeah.
So 4-piece laminated glass.
There's no midspan support. Is it
The
just
mid
hanging-
transport is this one, the
Okay.
slice,
Just the splice.
just the
Okay.
slice.
Wow.
So it's one tall, and
That's huge.
I have like many slices along the length. So now I go to the Address Boulevard. It's also in Dubai. The load is a 32 PSF, 12 PS, 12.5, and there I have a fall arrest, which is like a BMU. So you hang yourself in there, and then you have to clean. So The cleaner can go left and right. My scope here actually are all canopies. I'm not digging into the panels. All canopies at the back, all the entrance, and the sides of the building. How long is this? It's like 860, 26 meter. It's 85 feet long facade. And this other part is around 120 feet long facade. So if you see the steel structure, these are all fabricated because one RHS cannot pass. And it is actually, as we go on from the back side up the front, it's a tapered connection. It's getting smaller, smaller, smaller. You have to fabricate everything according to the steel. And here are the bracket details. A rebar is being used to hold up this particular bracket at the midpoint because it's cantilever. It's cantilever and
Canopies cantilevered off the structure.
full cantilever.
Wow.
The brackets are only here. See, 1, 2, 3, 4, 5 at the back. That's it. So how we are bracketing it.
How far does it stick out?
It's 85 feet wide,
Right.
and this is around 21 feet, 20 feet.
So cantilevers out.
Yes. So the brackets are like, see how many anchor bolts that I have to put in just to make this work, and how many rebars that I have to like drill up 12 inches or 16 inches along the concrete just to make this work. And this is like how we do the splices, okay, the moment splice connections, because as I've told you, we are bringing in steel from a 20-foot or 36-foot trailers, putting it on site by a crane, and then installing it together. And then we go to the metal panels. This is aluminum composite panels. Actually, I do all of these things, any shape, any length, as long as you can, in the finite element analysis. Okay, so any question on that? Nothing? Okay, so I'll go to Al Hikmah Tower. My scope here is the elevator shaft, wherein you see everything. It's a panoramic view. So a steel frame located at the center of the building, from that point above the canopy up to the upmost part.
So it's your scope is the elevator shaft, the
Yes.
transparent elevator shaft?
Yes. So here, these are the steel frames that I put in every floor with tension rods, point fixed glazing as well, and tension rods connection. So everything is in there in this model on the left side. Actually, this is straightforward, but I just want to show you, how point fixed with steel construction or tension rods are being installed on site. Okay, we can go back to there if you have questions. Okay. This Mall of Qatar, if you see those skylights, all of my scope here are the skylights. So we have different types: spiral, a dome, an oval shape, rectangular. I have a V shape. I have all the skylights. On the left side is a spiral skylight. So it's a staircase. The glass is going up. The right side is a dome skylight. By the way, it's also made up of tension rods because it's huge, quite huge. And here it's an oval skylight. And I'm also doing bracketing using finite element analysis because of the huge loads. And the canopy on the right side. And that's about it. There are still a lot of skylights in that building. I'm showing you some parts of it. So now I thank you. It's open.
Yeah, Ivy, what are the so I'm guessing, are there typhoons on that area, or what's the Indian Ocean equivalent of hurricane?
You want to see the
There is no typhoon in there.
And the screen.
There's only sandstorm in there.
Sandstorms, okay.
Yes, but it's not like wind load. It's just a sandstorm putting on like sands everywhere on the sunshades or so. No, there's no additional snow load or not even an earthquake actually.
Yeah, there's no
but
seismic activity in that area?
There is like small, in the last 5 years, I think there is seismic.
Seismic loads are not, they didn't govern most of the design?
Yes, it's all wind loads that's governing on the design.
I
So
have
it's-
one question, Ivy. Is there any additional analysis because of the delta temperature? Because I knew that for Arabia Saudi and Qatar, places that you built, the change in the temperature is really really
Yes.
tough. Because in the daylight it's really hot, and in the night as a typical desert is really cold. So is there anything else that you did?
Yes, there is a temperature load on all my steel. And actually, the temperature loads are being dealt with the slotted. I have a fixed and a slotted. So whenever your steel members contract or elongate, it will not have a problem with the reactions. So all of the frames that I'm showing have temperature loads up to 75, depending on what the specification is. But most of the time it's 50 degrees Celsius, 5 to 50, something like that.
Hey, Juan Pablo, can you still see the screen?
Nope. I see you guys. No, I can see the screen.
Okay.
I can see the
All
screen.
right. Okay.
So a couple of questions. You've talked a lot about the steel. Are you also analyzing the aluminum members as well? Okay.
Come on.
And what's the time period on these projects?
Okay. For the SABIC, it's 2 years. For Alwasel Tower, it's 2 years. So I'm working on like full time, 2 years. For the first 6 months, 8 months, no sleep, even Saturdays, because it's one-on-one. As I've told you, it's one-on-one. So you have to deal in like, what's the priority here? Give me a list, 10 lists. What's the priority here? So you just have to prioritize everything, because everything is like kind of, it's a pressure. It will be, if you think about it, it's a lot of pressure.
Are you doing some of the design as construction is going?
Yes, actually, because
So it's design build.
consultants doesn't know how to fix it on site.
Yeah.
They will just send like a Revit or a BIM model.
Yeah.
Then I will take it from the BIM model and design how I'm gonna fix the curtain wall from there on. My position in that office is that when I was sitting there in the office, as I've told Carrie, I cannot even like work like 3 hours in a day, because every 10 minutes somebody's coming in, because I have to sign in all the shop drawings that needs to go out. Even though we have the design manager, she's passing it to me, because the structural parts need to be signed off by me. Even the material takeoff, I need to sign it off. So it's like a full package thing. So I need to read on the shop drawings. I need to check everything. It's same with the calculation before I even.
What kind of code do you use when you're analyzing
This is British UK.
the British? Okay.
But at some projects you are using American code, but it's actually dated. ADM, I mean, it's 2010 is the latest that they're using there. 2005 is still acceptable there. 705 still acceptable there. So.
Did you have any target amount of hours you had to hit on any of these projects, or is
Oh
it
yes.
it's kind of like
No,
go for it?
actually we have a target, but then again, because of some issues, you have to do this first. Okay, I know we agreed to do this, but you have to do this first. So you just need to prioritize everything, because it's not possible actually to do the target. And there's one time that my boss asked me actually 5 calculations to release in 3 days. So I have to do it like not sleeping at all. We don't submit this on time, the company will be penalized. So
Who's the owner, Ivy? Is it the government of Qatar? Is it the prince, the king, or who's
different owners of this. These
like
are
investors?
like the SABIC, it is owned by the oil company SABIC. So address is like a shape. It's like owned by a shape.
Did you do any cable stay systems?
Yes, I did. I did not show it here, but I think I showed it.
Yeah, that'd be cool to see, because we
It's-
really haven't done any cable.
So the
stay
cable
systems.
system that I've done is just one piece, top and bottom, pin connection. So
One we've done.
and it's
And,
point
and connection at the top and the bottom, it's just pretty, yeah.
and there's a point fixed glazing.
I think you briefly touched on this, but I didn't hear the answer. So whenever they come up with a budget for, the building and the construction, part of that is engineering budget. How is that? How do you know what your budget is in those projects? You don't know what the budget is in
It's only the owner of the company. I'm just being paid like.
and they're basically saying, hey, we just got to get this done. This is the next part. Got to get it done.
And they're saying, okay, we got this for 2 years. Of course, they will not say 2 years. They will say, we got this for 1.5 years. Right? And then,
It's for
but
three.
you know,
That's it.
it will extend up to
Yeah.
You have 3 days to get this done. You really have a month.
what I've
My-
known is like in And this one project that the one with the problem on the steel, I've seen the quotation. It's like, I don't know, it's an AAD.
Thanks, everybody.
Thank you, Ivy, too. That was an awesome
Thank
presentation.
you, Ivy.
Yeah.
Thank you.